Next talk is Down the Rabbit Hole, how hackers exploit weak SSH credentials to build DDoS botnets, and the talk is given by Christophe Tafani-Dereper. Thank you, Christophe.
So, hi everyone. I'm very happy to be here today. So, in this talk, we're going to take a look at SSH servers and how they are exploited in the wild to create a network of exploited machines that is later used to create DDoS attacks. So, a few words about me. I'm a master's student at EPFL, which is a school in Lausanne, in Switzerland. I'm interested by everything related to AppSec, malware analysis, and DevOps. And currently, I'm doing a master thesis in a company called LK in Lausanne, which does software engineering, system integration, and also has some cybersecurity services. And in the past, I've worked in a money transfer company named TransferWise. And yeah, basically. So there is three main goals in this talk. In the first part, we're going to take a look at the kind of automated threats that are targeting the SSH servers on the web. Then we're going to take a malware sample that is exploiting these to create DDoS botnets, and we will analyze it together. And then in the end, we will suggest some things that we can do to protect ourselves against this kind of things. So this started by a question that I asked myself one morning, which was, what happens if you leave a server completely insecure on the internet? And that was an honest question. Like I didn't know if people were going to mine some Bitcoin on it, if they were going to maybe destroy it or send spam. And yeah. And so I set up a honeypot, which is essentially just a Linux box that you can connect to via SSH with any credentials. And the way it works is that basically anybody can connect to it with any password. And then they get something that looks like a real shell, but is actually emulated. And so you can log everything that happens on it. So typically it looks like this. You have your standard SSH server, the real one that is listing on a non-standard port. And then you have your honeypot, which is on the standard port 22, listening for connections and accepting any connections with any credentials. And so if you try to connect to it, you would get something that looks like a shell, and you would be able to run some commands in it, but they are not real commands. So basically it's just a basic honeypot. So I thought I would have to wait for a few days before seeing anything interesting. And basically I was surprised because after a few minutes I already had some people that were trying to connect to this honeypot, which is quite interesting because it was an IP that I was just started using a few minutes ago and that I never used before for anything. So we're going to show a few stats about the things that happened during 3 days. So basically in 3 days there were about 2,000 connection attempts coming from 187 unique IPs from a lot of different countries. And just a few stats. So the main attack patterns that I show was a lot of SSH bots, essentially bots and just programs that were trying to brute force some common SSH credentials. And once they managed to find some valid credentials, which in our case was anything, they would, whoa, sorry for blurry text, they would start to download a binary over HTTP or TFTP, and then they would just execute it. So a few statistics about the most popular passwords that were tried first. So we can see that the most popular password was the empty string. And then we have also some interesting things that you might not see, which is some default passwords for embedded devices like Cisco or Realtek. And also we have some Dreambox. And similar patterns happens for usernames. So the admin username is not the one by default on Linux systems, most of them. And this is the one that comes first. And interestingly, this is the one that is by default for some firewalls like pfSense or Cisco, and also for the OpenWRT distribution, which is a distribution for embedded devices. And so this is clearly a malware that is also targeting embedded devices, and we'll see why in a few moments. And this is just some stats about the attacking IPs. So it was mainly IPs that were seeming to come from Russia and China, basically. So about the malware families that were dropped, so mainly three. The first one is XOR DDoS, which is the malware that is implanted on SSH servers, also on Linux boxes, and which then is used to create a network of machines that are later used for running denial of service attacks. Another one was Mayday malware family, which is similar in its feature set. And we also had some Tsunami backdoor, which is just essentially a backdoor for Linux systems. And there were also a few bots that were probably outdated and that were trying to download stuff that didn't exist anymore or didn't run correctly. So this is to show a general architecture of a botnet. So at the top of it, you have the attacker, which is in control of everything and which doesn't want to communicate directly with the exploited machines. And basically, he wants a layer of anonymity between him and the machines. So what generally happens is that there is a command and control server between the attacker and the exploited machines. So this can be machines that are owned by the attacker, or it can be some vulnerable machines like an outdated WordPress install that is used to do that. And then when an attacker wants to run a DDoS attack against the target, he would instruct this command server to tell all the exploited machines that he wants to run an attack, and in their turn, they will run the attack themselves. So what we're going to do now, I'm first going to try to make this mic work. And no, should I use this one? Thank you. Okay, so what we're going to do is we're going to take one of the samples that was dropped on the honeypot, and we're going to analyze it with some various tools to see what it does, how it behaves, and yeah. So the first thing that we can do, yeah, and just some comments. So this is a malware that was active so 2 years ago mainly. So it had been used to launch DDoS attacks mainly to targets in Asia. And I thought it would be interesting to take a look at it because the techniques that it uses are still relevant today, and it's still quite simple to analyze. So I will try to do it in an interactive way. So I won't show some walls of assembly or things like this, and hopefully it will be interactive and useful. So this is the commands that the bots are using to drop the binary on the server. So essentially, it's just a wget followed by a curl, and then the execution of this binary. So nothing very fancy here. And then the first thing that we can do is to do some very basic analysis on the binary to see what it does and what we think it might be doing. So using the Linux file command, we can see that it's a 32-bit executable for Linux, and that the debugging symbols were not stripped. So essentially, we can see the function names, the variable names in it, and this will allow us to have an easier time to analyze it. So knowing that, we can read the symbols that are stored in this binary and grep on everything that looks like a source file. And we get already an overview of what this malware could be doing with things like autorun.c, so we think that probably is going to try to run a startup. Encrypt.c, so we might think that there's going to be some kind of obfuscation, sorry. Hide.c, so we can think there is going to be some rootkit features to hide its activities or things like this. And yeah, so with two very basic Linux commands, we can already have a quick peek at what we think it might be doing. And then we can be a bit more involved and open it in a disassembler. So I hope you can read that. So what the malware does when it starts up is going to decrypt some configuration values that are being stored encrypted in the binary, which are the one I rounded here. And essentially, it does this by calling a decrypt configuration procedure, which is just a call to a function named encrypt code. And what this function is going to do is it's going to do a XOR byte by byte of these values hard-coded in the binary with another one named XOR keys, which is essentially a XOR key, as its name implies, which is stored hard-coded in the binary. So essentially, yeah, this is very basic encryption. And so if we want to decrypt it, yeah, so this is used by the malware in several places. So first to encrypt some configuration. which is stored hard-coded, and also to encrypt its network communications, as we can see here in the decrypt remote STR, this is called, and also in a TCP thread procedure. And so we can quite easily like reverse this encryption. All we have to do is to implement it, for instance, in Python. So it's just a XOR byte by byte with the key that we found in the binary. And then we can take one of the configuration values that we find in the binary. We just apply this algorithm to it, and in this case, we get something which looks like /user/bin/nullbyte, which seems quite reasonable for C string. And then we can do this for every value that we find in the binary, and we get a bunch of paths. Okay. Along with along with some URLs. So we can see here that there are 2 or 4 URLs that are stored in the binary encrypted. And so this is some links that the malware uses to download some dynamic configuration when it starts up. And essentially, it's going to find in it things like the URL of its command and control server and some additional configuration so that it's easier for the attacker to update it, basically. So unfortunately, it's not accessible anymore, so I wasn't able to show it to you. But some other analyses have shown that this is the kind of things it contains. And yeah, this is a domain which looks to be registered from China. You even have an address if you want to send a Christmas card. And yeah, so the next thing that the malware is going to do when it boots is it's going to run a bunch of Linux commands to gather some information about the system, like what user it is running on, how much memory the machine has, what kind of network interfaces it has. And then it's going to encrypt it using the same thing that we saw a few minutes ago, and to send it to its command and control server. So in the code, it looks like this. Even if you can't see, I will describe it. So it's going to get some information about the CPU, then about the network interfaces and what kind of network speed they can have. And it's going to encrypt all these things and to send it to its control server. So that is going to spread with a number of different ways in the system. So first thing it's going to do is to copy itself into some files that looks quite normal. And then into this file is going to append a random string at the end, sorry. And probably this is so that if you're just looking for it with a hash, with MD5 hash, for instance, you won't find it because it would be different for every infection. And yeah, so this is just a strace output which shows the system calls that it is doing. So it's just opening this binary, going to the end, and then writing a random string at the end. Then it's going to create a system service, which will be valid both for CentOS-based system and Debian, so Ubuntu also. And so it's going to use both commands just to make sure that it works on multiple class of systems. And it looks like this. So essentially, it's just a system file, which is a service that can only start the malware itself. So this will cause it to run at startup automatically. And because it's really paranoid, it's also going to create a cron job, which will run every 3 minutes. And this cron job is essentially a bash script, which is this one, and which is doing 2 things. It's looping through the network interfaces of the machine, and it's going to make sure that they are started, just in case you disable it because you thought you were maybe infected. And then it's going to make sure that the malware is running in case it was killed by somebody. Then an interesting feature of this malware is that it's going to use a feature of the Linux kernel called the loadable kernel modules, which is a feature that allows you to insert some kernel modules in the kernel at runtime, so without needing to recompile it. So this is done typically with the ensmod command. And so the malware uses this by creating a virtual device, which is proc rsdev, and then it's going to hook some Linux syscalls in order to hide some of its activity. So typically, it's going to hook some file-related syscalls so that it will be able to overwrite some standard syscall and then it's going to be able to hide some files that it creates. So we can see here that there are two functions, hide PID port and hide file. And this is the code of the hide file procedure, which is essentially opening this rootkit device and then using the IOCTL syscall to instruct him, so to instruct the code running in kernel space, that it should be hiding this particular file. And what this will do is that in the kernel space, when you will do, for instance, fstat or an open syscall, the malware will look at, okay, am I allowed to say that this file exists? And if no, it's going to say that it doesn't know the file. And otherwise, it's just going to proxy it to the real syscall, basically. So this will allow it to hide some of its files and some of its network activity. And we might think that this is a quite hard thing to do, but actually there are a lot of LKM rootkit on GitHub. I found another one just yesterday, a brand new one. And if you want to have some resources on the topic, there is a one from Sans, which is quite interesting. So then we're going to take a look at how it communicates with its control server. So there are several things. So essentially, the malware is polling on its control server in order to retrieve some tasks that it has to do. And one of these tasks can be to download and execute a file. Another one is to update itself. So it's a convenient mechanism for the attacker. They don't have to reinfect every machine. And it can also remove some files and kill a running process. And this is interesting because it appears that it is used to kill some competitors' malware, meaning that essentially it's going to look at the processes that are running, and if there is one that it doesn't like, it's going to kill it. So you might have two different malware on your system that are going to kill with each other. Yeah. And then the last thing that it can do, obviously, is it can run a DDoS attack. And so it receives a particular opcode from the server. And based on this opcode, it's going to be able to run 3 different types of DDoS attacks. So the first one is going to be TCP SYN flooding. The second one is a TCP ACK flooding, and then DNS amplification attack. So basically, the TCP SYN flooding is that you send a bunch of TCP SYN packets to the server, and at some point it will become overwhelmed and it won't be able to accept any new connections. The TCP ACK flooding is the same, except that it's a bit less effective, but it will be able to bypass more DDoS prevention devices. And then the DNS amplification is based on the fact that DNS query can be much smaller than the response, and then it leverages this by sending some legitimate DNS request with forged source IP address, and then the DNS server is going to answer to the victim with a query an answer that is much larger. And yeah, I had some schema for them, but I think yeah. So a few conclusions that we can take away from this. So some of them are very basic. Obviously, maybe a few years ago it was true that if you had an IP that you never shared, it was kind of secure because nobody would know it. But we are 2017, so there are a lot of projects that are scanning the whole internet every day, maybe every hour also. There are projects like Shodan and Sunsys that you can use to query the whole internet IPv4 database. So yeah, we have to make sure that our public IPs are well protected. And also, it's probably a good idea to use strong SSH passwords, obviously, and also private key authentications for 2 reasons. First, because you're much less likely to register to a fishy website with a SSH private key, but you are maybe with your passwords. And then it will be also stronger than any password that you could think of. Then there are some very basic things that we can do against brute forcing. So for instance, we can use file2ban, which is a very simple tool that is looking at the logs and banning some brute force attacks based on what it sees in the logs. So this is an example where you configure it in order to only allow 3 failed attempts in a window of 5 minutes before banning the attacker's IP for 1 hour. And then there are some IDS and IPS like Snort or Suricata, which have a quite high number of rules that are free. And in this case, this is the snort rule, which is used to detect the malware that we just saw. So essentially, it matches on the URL that the malware calls to the control server. And it does two things. It's going to raise an alert so that somebody in the IT team is going to see what's happening, and so that it's going also to drop the packet so that the malware won't be able to communicate with its CNC server, basically. Yeah, and managing some rules for IDS that are rule-based can be a bit hard. So there are some tools that we can use to do some automatic updating and these kind of things. Because if we have an IDS but we don't update its rule set, it won't be very useful when there is a new threat that is going to come. So I think we're coming to the end. I think I'm a bit early. So I have a few resources that you won't probably be able to read on this screen. So you can download these slides if you want at bit.ly/GreHack17-malware. And I linked a sample to the malware that we analyzed. So if you want to download it yourself and take a look at how it works. And I also have a few resources about basic malware analysis if you're interested to take a look. And yeah, I will post the slides on Twitter also. Thank you.
We have plenty of time for questions. I can't see very well, so if you have questions, please wave your hand very high. Okay, sometimes of usual question, how long did it take you to make the whole analysis once after your 3 days of gathering things on your server?
So I think if you count in the time to set up a basic infrastructure with VirtualBox and these kind of things, maybe something like 4, 5, yeah, maybe 1 week.
And have you compared to some known attacks and know that this one was involved, or maybe your server was involved?
No, so in this case, it's not active anymore. But yeah, it was used in several attacks in a few years ago. I have a few screenshots on the slides, and it's mainly attacks that were targeted to China and Asia servers, so targets that were located in Asia, basically. Yeah.
But does it mean that, okay, you said that it wasn't active anymore, but does it mean that it continues to infect the servers even if it's not active?
Typically, I think these are maybe some bots that were rented maybe a few years ago and that keep trying to do this, but like the CNC servers are not active anymore, so it's not. Yeah.
Any other questions? No? 1, 2, 3? Okay, if not, then thank Christophe again.